Have you ever felt like you were looking at two completely different universes at the same time? On one hand, you have this tiny, lonely traveler, Voyager 1, which has been screaming into the void for nearly half a century. On the other, you have the James Webb Space Telescope, a cosmic origami masterpiece, peering back to the dawn of time itself. One is looking out, the other is looking back. And what they're showing us is a universe that is both beautifully simple and impossibly strange. It's like having a detective who is at the scene of the crime and another who arrived 13 billion years later. What happens when we compare their notes? The answer might just change how you see everything. Stick around, because by the end of this, you'll understand why these two incredible machines are giving us two sides of the same cosmic story. Let's start with something familiar, a road trip. You pack your car, say goodbye, and hit the highway. Voyager 1 is the ultimate road tripper. Launched in 1977, its original mission was a grand tour of Jupiter and Saturn. But, like any good road trip, it just kept going. It's now over 24 billion kilometers away in what we call interstellar space, the vast, empty ocean between stars. It's the farthest human-made object from Earth. Think about that. A piece of the 1970s, carrying a golden record with sounds of Earth, is now a ghost ship sailing the cosmic seas. Its job now is simple: to taste, feel, and listen to the space asterisk between asterisk the stars. It's like dipping your toe in the water to check the temperature. This matters because for all our stargazing, we've never actually been asterisk and asterisk that water before. Voyager is our first brave little probe to do it. Now, let's switch gears to the James Webb Space Telescope, or JWST. If Voyager is a road tripper, Webb is the ultimate historian. It's not traveling asterisk out asterisk. It's looking asterisk back asterisk. How? Because light takes time to travel. When you look at the sun, you're seeing it as it was 8 minutes ago. Webb is designed to look so far away that it sees light from the very first galaxies, as they were over 13.5 billion years ago. It's a time machine. Webb looks at the universe in infrared light, which is invisible to our eyes. Why infrared? Imagine a song being played from across a huge valley. By the time it reaches you, the high notes have faded, and you mostly hear the deep bass tones. In space, as the universe expands, the light from distant objects gets stretched out, shifting from visible light into longer, redder, infrared wavelengths. Webb is basically a cosmic bass detector, picking up the ancient songs of the first stars. So we have Voyager, our scout in the immediate neighborhood, and Webb, our historian looking at ancient history. Here's where it gets interesting. Let's start with Voyager's perspective. For decades, we imagined interstellar space would be a calm, empty void. Layer 1. The simple explanation. We expected a gentle cosmic wind, the solar wind from our sun, to slowly fade away, replaced by a new, equally gentle wind from other stars. But that's not what Voyager found. Layer 2. The complication. As Voyager crossed the boundary, it didn't find a calm ocean. It found chaos. The cosmic rays' high-energy particles from distant supernovae were far more intense than predicted. The magnetic fields were a tangled mess, like a bowl of spaghetti. Here's your first wow fact. Voyager is currently being hit by cosmic radiation so intense that if an astronaut were standing there, they'd exceed their lifetime radiation limit in a matter of days. The empty space between stars is actually a violent, fizzing sea of energy. Now for Layer 3, the cutting-edge part. Voyager has discovered a whole new region of space we didn't even know existed, a sort of cosmic purgatory called the heliopause. It's not a smooth boundary, but a turbulent, frothing foam where our sun's influence crashes against the rest of the galaxy. Recently, Voyager detected a faint, persistent hum in this space. It's the sound of the interstellar medium itself, vibrating like a plucked string. We are literally listening to the sound of the galaxy. Now let's pivot to Webb. Webb is looking at the big picture, the birth of galaxies. Layer 1, the simple theory. We thought the first galaxies would be small, messy, and disorganized. Like baby pictures, they should be a bit awkward and unformed, slowly growing into the grand spiral galaxies we see today. Layer 2, the but wait, it gets weirder moment. Almost immediately, Webb started finding galaxies from the cosmic dawn that were shockingly massive and well-structured. It was like finding a fully grown adult in a nursery. These galaxies, which should have been toddlers, were already building complex structures and churning out stars at an incredible rate. It breaks our models of how galaxies are supposed to form. It's like finding a fully built skyscraper in a historical photo of a small, ancient village. It just shouldn't be there. And here's layer 3, the mind-bending part. And your second wow fact. Some of these early galaxies are so unexpectedly large that they challenge our understanding of dark matter. Our current models say dark matter, this invisible cosmic scaffolding, is cold, meaning it clumps together slowly, allowing small galaxies to form first. But these massive early galaxies suggest that dark matter might have been warm or fuzzy, allowing it to clump together much faster. Webb's photos are so revolutionary, they re-forcing physicists to go back to the drawing board on one of the biggest mysteries in the universe. So, how do we connect these to wildly different stories? Voyager is giving us the gritty, tactile reality of our immediate cosmic environment. It's telling us that space isn't a serene backdrop. It's a dynamic, powerful, and hazardous place. It grounds us. It reminds us that for all our grand theories, the universe can still surprise us right on our own doorstep. Webb, on the other hand, is rewriting our origin story. It's showing us that the universe was in a hurry to create complexity, to build beautiful, grand structures right from the beginning. It tells us that the cosmic story is older, faster, and more dramatic than we ever imagined. Together, they paint a complete picture. Voyager gives us the now, the physical reality of what it's like to be asterisk in asterisk, the galaxy. Webb gives us the then, the epic history of how it all began. One is about the journey, the other is about the destination we've already arrived at. It's the difference between reading a history book about an ancient empire and actually walking through its dusty, bustling streets. You need both to truly understand. These two missions reveal a universe that is both a violent, crackling sea right outside our door and a breathtakingly creative canvas that started painting masterpieces billions of years ago. So, let's recap this incredible journey. We have Voyager 1, our lonely scout, braving the chaotic sea of interstellar space and literally listening to the hum of the galaxy. And we have the James Webb Telescope, our time-traveling historian, showing us that the universe was building monster galaxies when it was just a baby, forcing us to rethink everything we thought we knew about cosmic evolution. Voyager tells us where we are, and Webb tells us where we came from. They are the two most important explorers of our time, one with its boots on the ground, the other with its eyes on the dawn of creation. My final thought for you is this. If the universe was in such a rush to create complexity and structure right at the beginning, what does that imply about the potential for life? Does a faster start mean more chances for life to arise? Thanks for exploring with us on Sciences and Facts. Let us get a debate going in the comments. Do you think Webb's discoveries mean our models of the universe are just a little wrong or completely broken? Let me know. And if you enjoyed getting your mind bent today, you know what to do. Hitting that subscribe button is your own personal mission to explore the cosmos with us. See you next time.